Don't attach your whole life's ego to what plan you had when you were 15 years old. If my 15-year-old self looked at my 50-year-old self and said, I am disgusted by your path in life, too bad. You're not the same person I am today. And I'm not the slave of my 15-year-old self. You should not just get a problem handed to you and then work on it like you're a pack mule or something like that. It's fine to receive a problem from your elders, but then you have to take it into yourself and say, that's a fine suggestion, but based on that, I'm going to reformulate this in my mind and think about what is the real problem I want to solve.
Too hard to predict right now whether these LLMs or these transform-based systems will truly do novel research themselves. I suspect they will, but I am 100% confident that they're going to make the world's best scientists an order of magnitude more productive and more novel themselves.
But on the LLM space, I think the thing that's become really apparent is you can do a lot of casual brainstorming and do it with your buddies. You can now do it by having a little bit of riff session with whatever GPT is the most useful. Or in early days, so some of the stuff is delusional and incorrect. But if you're working in a domain where you have some domain expertise, it's not a big problem for you to catch those problems along the way.
Hello, everyone, and welcome to the -1 podcast. I am Aditya Agarwal, your host. I'm a partner here at South Park Commons, and I'm very excited today to welcome a dear friend and renowned physicist, Rana Adhikari, to the podcast. Welcome, Ranaji. How are you today?
Thank you for having me. It is always great to have conversations with you. Always looking forward to it.
Amazing. Well, Ranaji, why don't we start? As you know, a lot of our podcast kind of explores the winding paths that people take towards finding their life's work and towards greatness, because our thesis at South Park Commons is that it often, it can take some time to figure out, which mountain you should scale, what are the problems worth tackling. So maybe, my first question to you is that you call yourself a mechanic, who turned into a physicist, right? But talk me through some of your early journey. How did you figure out that this was your life's calling? Like, what signs did you have? What threads did you pull on? How did you converge on this?
I think accidentally. I feel almost embarrassed when I talk about this thing because other people in my area in physics, they have this origin story which is way more clean. And they'll say something like, when I was 9 years old, I thought about black holes and therefore I went into this subfield or something like that. But I didn't have any of those kinds of interests. At that age, interest is like playing, meeting girls, having fun, like partying, that kind of stuff. It's a normal. There was no physics call to me, or like physics and mathematics is not specifically that interesting to me, I think. But like a lot of people, I was lured into this kind of area through science fiction. And that I didn't think about it as a career. It was just one of those things that's super interesting to think about and talk about all the time. All these spooky concepts like other universes and time travel. It's just, it's a great lot of fun. And it's always there in things like Star Trek and movies like that.
Do you think that most of these origin stories that people narrate about their lives are somewhat like backwards constructed? Because human beings, I think, particularly as you get more renowned and more famous, I think you almost need a consistent story of your own life narrative in your own head. And it's easiest when you have it be simple. Listen, I was always into this stuff since I was 8 years old. And it's a simple, clean narrative that you can hold in your own head. But I've had the opportunity to work with a lot of folks who are well known today. And I do think that origin stories are often far messier than people kind of like remember them as,
Yeah. And we should make this clear, I think, because when you're like 20 years old and you're trying to figure out your life, what am I going to be? And there's a lot of anxiety about it because you look at all these other stories and you say, wow, I'm 20 years old and I haven't done this thing. And I talk to other professors at Caltech and they tell me things like, when I was 14, I really struggled with the Feynman lectures. And I think I would have struggled to lift to them, but that's about it. I don't even know what to struggle with. And people should learn this thing that it's fine to be confused and disorganized and have multiple interests and not know these fundamental things. What should I spend my time to? How should I spend my time? And it's a struggle that just goes on forever. I'm convinced this day that it will never end for me. By the end of my life, I'll still be thinking, what should I spend my time doing today and tomorrow and so on. I think it's fine. My experience is that if you've been on a really, cleaned up path, if that is your true origin story, you're kind of a boring person today. And the most interesting people to me are the ones who got lost along the way, and it took them like 8 years to finish their bachelor's degree or something because they had a lot of life experiences. They got involved in trouble, or they had personal problems, family problems. They went into something else that was interesting for a while, then came back, or things like this. You're more, I don't know, I think you can solve problems that are more interesting if you have a wide patch that you're starting from. You're familiar with things.
Yeah, it's really interesting, man. Like when I hear kind of like, some people when they're on podcasts or they're writing and they have this super crisp definition of the problem that they're working on, the solutions that they have, my first reaction is like, that problem must not be very hard. Because most of the times when I meet people who are working on interesting things, it's super messy. They're like, oh man, like, I thought I knew the answer, but then it turns out I spent 1 year kind of chasing the wrong thing. And then I kind of tried out something else. And then I kind of got lucky and I figured it out. But then that luck went, it was 3 steps forward, 2 steps backward. It is so squiggly. It is so winding, And I think in some ways, embracing that this is supposed to be kind of hard and messy and non-linear and sometimes backwards, I think actually frees, it frees me, right? Like when people ask me like, hey, what's your 10-year vision for SPC? I'm like, I can kind of tell you what our North Star is, but I don't actually know the exact path we are going to take because we'll have to figure it out because it's too hard to predict.
It's a great exercise to try.
Fair.
Yes. And then you can throw it out and don't attach your whole life's ego to what plan you had when you were 15 years old. And so what? If my 15-year-old self looked at my 50-year-old self and said, I am disgusted by your path in life, and why didn't you join this band and become famous in stadium concerts? Too bad. You're not the same person I am today. And I'm not the slave of my 15-year-old self.
Sure. Yeah, planning is more important than the plan. The act of planning is more important. Absolutely. Here's a question for you. So your PhD advisors were Rainer Weiss and Peter Frischtel, right? Great. O3 got it right. Thank you. So my question to you is, what is the single toughest lesson that they kind of like passed along to you that maybe today you still recursively pass along to your students?
It's nothing about physics, really. It's about what's the right approach to working with people. How do you get the most out of people? And, how do you approach problems? How do you state the problem in your mind and think about the problem? And then the next step is something like, what is the sphere of the problem? Am I trying to solve something like changing the planet or changing the universe? Or am I working on something that's more about myself and my internal mental state, or what are we really at here? And the thing that I learned most from Peter was that you should not just get a problem handed to you and then work on it like you're a pack mule or something like that. But it's fine to receive a problem from your elders, but then you have to take it into yourself and say, that's a fine suggestion, but based on that, I'm going to reformulate this in my mind and think about what is the real problem I want to solve, not what they've given me. And there's a clean example of this I remember where we were sitting around at the LIGO observatory and there's some technical problem. And I said something to him like, blah, 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 like we can only improve this by this amount because that's what seems to be the common wisdom. And he looked at me with this kind of amazed look and was sort of like, oh, I didn't think you were one of those people. And then that was the end. And what he meant by that was, I thought you were different. I didn't think you were the kind of person who would stay in this side of this little box and solve the problems according to the rules they'd given you. But you should think for yourself and say, what do you want to solve? And since that point, I remember that occasion and I think about that whenever a problem comes up. That is this the problem that we should be solving, or is there something more fundamental? Should we rewrite the problem from scratch?
It's so powerful because this is often the voice that is going on in my head as well. right? Like when I'm basically, there's a particular problem statement and I'm kind of going back and forth in my own head about different solution sets. And often I land on something that feels a little bit against, I would say normal advice. And then the first question in my head is like, well, why are you trying to reinvent the wheel? And then my second answer is, well, because I think my situation and circumstances are different, right? Like I have taken the advice that has been the normal advice, but then ultimately I must make my own decision, right? Like otherwise, it's just, what is the interesting thing there? Otherwise,
You're not an NPC in the game of
yeah,
life, right? You're supposed to be a PC.
yeah,
And so your job is not to stand there and like hold up the wall or be part of the scenery or something like that.
right.
That's not your job. Your job is to determine the course of your life. And at least inside of here, you have full control over what you want to do. And that means both on the actions you take in your life, the people you associate with, like what are your inputs and outputs? It's up to you to determine your future inputs and outputs. And if you get constrained by these things and say, well, I have this toolbox and this toolbox is the only tools I can use. And so I'm limited to this box. I guess that's your own fault. At some point, someone has to tell you that you are allowed to go outside of that box, find new tools, find new problems, leave this, just, quit your job, quit this life. At the end of the day, you have to look back at your own life and say, yeah, I'm glad that I did those things and I took this winding path. And it doesn't matter. There's nobody else's score matters.
The other thing is that often in my role at South Park Commons, I will have a founder ask me like, hey, Aditya, what are some problems that you think are worth starting a company for? And immediately I'm just like, man, I can kind of give you some ideas, but the last thing I want is somebody working on my ideas, like I can relay them to you, but my sincere hope is that you make them your own idea, because these are things that I might have spent 20 minutes thinking about, 30 minutes thinking about, but as an entrepreneur you have to spend 5-10 years thinking about it. So like what's captured my attention for 30 minutes should not be sufficient for you. And it's interesting. I'm curious, like in your, maybe the question here is one around academia. Like, is that a pattern? Do you find that professors or researchers want students to work on their own thing, or are they comfortable kind of like giving a very small kernel of an idea and then letting it go where it goes? I'm curious how this plays out in your part of the world.
I'm now self-secure enough. I can talk about this, but
please, yeah.
I've done this very badly in the past. And so this is sort of my confessional here.
Okay. Yeah. Your atonement. Okay.
I was a bad mentor in my early days. And so I can tell you both things, but
they say, I want something, bite-sized, like you give it to me, I'll work on this problem for a few years. There are not a lot of other people working on this, so it's not a crowded field. There's no real deadlines. I don't need very intense funding to do this thing. And at the end, I'll be famous and solve a really fundamental thing about the universe. And I always have to say, if I had those things already sitting in my pocket, why would I give it to you? Because I would have just done it myself on the weekend, and it would
100%.
Be my 5th Nobel Prize or something like that. I'm not doing that kind of thing. I think the problem that you outlined, though, is there's a lot of people who are thinking, look, I'm the general of this army. And so what I want is a bunch of lackeys, and I'll give them orders, and they'll go out and do the particular nuggets of work that I need. And if I assemble all of these individual workers, my empire will be built and my genius idea will be pursued. And that's a kind of mentorship style that is out there. But I think the best scientists are not interested in that kind of thing. But what we really want is to work with people where after they worked with you, you later are proud of that fact. And you can say, when that person was young, I had a chance to work with them. And now they've left me and gone on to much greater things. But I was able to, enjoy that part of working with them as a young person. So it's the best, where you can, maybe you give someone a problem to work on for their first appetizer, but based on a few of those things, they come back to you in a few years or a few months and say, thank you for all of that wisdom that I learned during these startup things, and I got my training. But the problem that really fascinates me is this other one, which is off at 45 degrees from what you mentioned, but you may have not even thought about it because you're stuck in 20th century thinking. And the new problem is this whole other field which didn't exist when you were younger. We can get stuck in physics, right? We have a thing, here's a particle we're looking for. We can't find this particle. Let's use more and more resources to let's figure out this thing. But what about this whole field of other, complexity science over there, or cognition science, or computational things on substructures of solid state material? There's all kinds of things besides finding the next particle or figuring out something like gravity. We don't want to be constrained about with what physics was in the 20th century.
How did you get involved with LIGO? What were the early days? What's the origin story there?
I'm sure I've told this before, but I'm going to tell you the truth because
okay.
Now I'm old enough. I feel like it's time to come clean. There was no real good thought process. I was just sitting in a classroom, and I happened to be working in a gas station at the time for my basically pocket money or paying rent. And there was a kid in front of me. He turned around and said, what do you do for your pocket money? And I said, I'm working at the Shell station. I'm, wiping windshields or something. He said, yeah, I work in this lab downstairs. I wipe test tubes and things. I clean this lab. And I said, that sounds way better, because then you can put something about physics on your resume instead of gas station. How do I get that thing? He said, you just wander around and talk to people. So at the end of that class, I went to that professor and I said, if you're paying $5 an hour, I will work in your lab and clean whatever you want, because I'm only getting paid $4.75 at the gas station. And that guy said, well, that sounds fantastic to me. I'll walk around in the department. I don't have $5 for you, but I can find someone who does. And the first person that he found was a professor at University of Florida who was about to get involved in the LIGO project.
I can only imagine all of the different stories you can share about LIGO, because what a monumental kind of engineering project. So maybe, you obviously had to chase down a lot of obscure kind of, like I would say, noise sources, right? What's the most fun story you can share about finding gremlins inside kind of like your interferometers and so on?
People know we're trying to measure something super tiny, and it's equivalent to like the motion of a mirror at 10 to the minus 19 meters or something. So it's much smaller than the size of a proton.
Yeah.
So when it's like this, almost anything you can imagine that's vibrating or shaking in the environment, like electromagnetic fields, gravity, wind, earthquakes, traffic, everything matters. And it's a process of going through like a zoo and sort of crossing off all of these things. It's a little bit like paranormal investigation. There's some bump in the night and you wonder, is it from outer space or is it from this planet? And it's one of these nights I was sitting there by myself and one of the mirrors started moving by itself. And we have a lot of hundreds of thousands of sensors we can look at. And so I went through what I could. It took hours. I just could not find a source. What is making this thing move? And it was definitely not astrophysical. It was just really like something is drifting. And so I started wandering around the environment, the apparatus and the machine, trying to find what it was. And I went to one of the electronics rack, and there was just this awful, disgusting smell. And this was in Louisiana in January or February. And it's cold outside, like almost snowing. And so what happens is the animals try to come inside of your laboratory space.
Yeah.
And wherever you have electronics that are generating heat, that's sort of a cozy place for animal and vermin to come in. And so the rats were coming in and sort of falling asleep after having a nice meal. Yeah. They would sort of nest in the electronics. And a fluid would come from the rat at a certain amount of time, and that would connect two electrodes in a piece of electronics, and that would cause a mirror to move. And there's no way to monitor this kind of stuff. And so the next activity was to figure out how to do away with the rats.
So how did you do that?
It's very inhumane. We use glue traps.
That's a very reasonable thing. Yeah.
And it's not in my thesis.
Well, but this is an interesting thing to pull on, right? Which is that, a lot of large scale engineering, and something I've been thinking about is a lot of large scale software engineering. The best software engineers, they have a preternatural sense for where the complexity in a particular system lies, right? They have a preternatural sense for like how to hone in on sources of problems and issues. We can call that intuition, we can call that experience, but do you think that translates to experimental physics? Like some people just have better intuition than others. They kind of know how to hone in on like what might be going on. And what is the range there? Because obviously in software engineering, you have 1x to whatever 100x engineers. Like, do you find that same range in experimental physics as well?
Yeah. It's a tough thing to talk about because you'd like to feel like this is America, we're all equal and, we're all excellent and that.
Well, that was America in 2020, man. Like in this new America, apparently we are allowed to succeed again, and we are allowed to kind of like focus on merit and excellence, I think.
I think that was always the case. But you like to think everyone at least starts off at the same
That's
place,
true.
But
yeah,
it's not true, and it has to do with this winding path we've taken.
Yeah.
So when I'm like 6 or 7 years old, my father and I would sit around and work on old cars and try to figure out what's going on. And neither of us, I definitely didn't know what was going on, but he was new to the US and was also trying to figure out how do you work mechanically on these things and do it. But it was the culture back in the 80s, I think, that if man was a man, on the weekends, you would have your car up on jacks and be replacing parts or something like with all the other manly men. But at an early age, we were doing debugging, where we were doing things that were dangerous, like physically dangerous, getting injured, and trying things without having any manual or knowing what was going on. But over time, you would build up a mental model of what was going on. And I think in physics experiments, this is what I've seen, that people who are extremely obsessed about the experiment and what's going on, they're dreaming about it like I do. You wake up in the middle of the night or in the morning or while you're taking your shower, and it's just going around and like, what's going on? And you're trying out scenarios in your head. And once you're obsessed enough, you've devoted enough of your brain space to that thing. And really what's going on is you're running a simulation. You have a little network inside of your mind, which is simulating the physics of your experiment. And you're just, you're Monte Carloing. You're trying out all these different things to see what will work. And different people see it in different ways. For me, it's very visual thing. I visualize the whole experiment, the electronics components that are inside of it, and the details of everything that's going on. And you try to run that simulation to see in what situation with this behavior that I'm seeing, how could it really happen? And of course, you can do it all. If you don't have the intuition, then what do you do? Like what Ray Weiss would say to me when I was a student, he said, because computers are so fast these days, even dummies like us can do things. And
I love that.
I understood what he was saying. It wasn't an insult, but he was saying it's the great leveler. If you are not, like Wigner himself and can do it all in your mind, you can do it with computers. You don't need to have all the hardware up here. You just need to have the passion to take the effort and do it. And it's like that. When I meet people who have that kind of sense of their experiment, it has nothing to do with my experiment, but whatever they're doing, I can tell it's that kind of person because you can ask them all of those what if questions and they don't say to you things like, don't worry, man, we're really smart. We understand what we're doing. Instead, they'll say to you, yeah, that's a great question. And this is why we think this is the right answer, but we're open to other things because we need to improve.
Yeah. It's such a good observation around your brain essentially running a bunch of these simulations like in your subconscious space, because the same thing used to happen to me when I was writing like essentially like a lot of code, where I would wake up with kind of amazing ideas essentially on how to solve a particular problem. Or if I was debugging a particular like deep, often Heisenberg, which is only showing up sometimes and it was often deep in the kernel layer. And I would wake up with like interesting ideas of like things to try to break the system. So I would reproduce some parts of it. And, it's kind of one of those classic things where I learned this over and over in my life, which is that sometimes in order to solve the problem, you must almost like not kind of clutch at the solution too tightly, right? Because the more you try to clutch at it, the more in some ways your brain cycles are obsessed with the act of clutching it. And you kind of just have to let your brain wander. You have to trust your brain a little bit, right? And you're like, hey, listen, like I don't have it now, but it might come to me. I just need to kind of like essentially let it wander a little bit.
It's something the old scientists knew. I realize now, When I was younger, I would look at them and say, well, you dinosaurs have nothing to contribute. This is all modern stuff. Go back to your vacuum tubes. But I remember one of them, a guy, Dick Gustafson, who has been in this project for a long time. There was a time at which time was precious on the machine because of cleanliness and electricity and all other things. And he advocated he went to the management and said, like, these younger people need more time to play with the system. And there's no way we can justify this to a funding agency. But I can tell you based on my intuition that they need time for unstructured play where it's just them on the machine. There's no supervisors around to criticize what action they're taking. They need to be stupid sometimes and try things and fool around and giggle and have that kind of unserious kind of investigation where you just get a feel for the system and you just explore strange corners that have nothing to do with the solution you're after. And that's the only way you can build up these really good mental models. I think that's what he was saying.
For sure. I'm curious, like, maybe what is your take so far on like these LLMs and these transformer-based kind of like models and how they apply to your part of the world? Do you think that they demonstrate intuition? Do you think they demonstrate novel ideas? Like, are they able to demonstrate risk-taking? Like, where are they useful? Where are they not? While keeping in mind that they are the worst they will ever be today, right? They'll only get better from here. I think this is the thing that most people, whenever they critique anything, I'm just like, guys, like, we're way better than we were 3 years ago. And today it's the worst that it will ever be. So let's not get super hung up on what they can do today versus not, because it's clearly going to get a lot better, right? So with that in mind, I'm curious, like, what's your take on it right now?
It's super great. I would just say, I got into neural networks maybe in the early 2000s because there was a Stanford professor, Bernard Widrow, who had been using neural networks to do the inverted pendulum problem. And I have been fascinated about feedback control systems because I've noticed basically in all of experimental physics, if you can make a really excellent feedback control system by shaping the reward functions and all of these things very carefully, you can do a lot better than what you would normally do with the kind of feedback they use for air conditioning or something like that. It's an PID loop. And the more complicated is your neural network, well, anyway, there's a lot of mathematics about it, but like you can make it's basically a nonlinear function approximator. And whether or not you can ever find the true nonlinear function that you need is kind of a up in the air thing. But the general wisdom around here, people said, don't get into this neural network thing. It was a fad in the 80s, and we long ago just debunked this thing, and now we're doing, I don't know, like bag decision trees or whatever.
Or like random forests or something, exactly. Yeah.
I said, yeah, whatever. I don't really care what's your optimizer or what's your optimization scheme. I just need something general enough that it can be tuned to do what I want. And it was really lame, I would say, back in 2005 or something. What you could do with it, it just, like backprop was there, but people really didn't know what to do with deep networks and how to really optimize these things. And we didn't know how to make the reward space correct so that you would really converge onto something. But now it's not like that. I'm involved in, I can't tell you that much because it's still under NDA, but I'm still involved in that line of thing. And hopefully some exciting results will be out in a few weeks about the use of deep neural networks for feedback controls. But on the LLM space, I think the thing that's become really apparent is you can do a lot of this like casual brainstorming you do with your buddies. You can now do it by having a little bit of riff session with whatever GPT is the most useful. And I do it all the time. I come up with something like a code base of several different programs to interact with each other, control hardware systems, or think about how to simulate a complicated system where I don't understand the physics yet. But you can come up with something it could be, as you said, we're in early days, so some of the stuff is delusional and incorrect. But if you're working in a domain where you have some domain expertise, it's not a big problem for you to catch those problems along the way. You can easily see those things and correct them. And it gets you, it gets you 90% of the way. And then the final layer may be, if you're really doing something new, maybe they don't have the power yet to do that last new part, but they can do all of the monkey work that's needed to get you to that point. And then you can innovate on that layer.
Yeah, it's I think it's probably too hard to predict right now whether these LLMs or these transform-based systems will truly do novel research themselves. I suspect they will, but let's kind of table that. I am 100% confident that they're going to make the world's best scientists an order of magnitude more productive and more novel themselves, right? Like even the act of like brainstorming with someone and to like that person to keep up on demand whenever you want, that's incredibly valuable, right? Like the amount of like writing that I do now simply because an LLM can kind of get me going a little bit, kind of get me into my flow. When I'm stuck, it can, essentially like, jog me out of it. I'm immensely more productive, right? So I think it's a very exciting time. And I think that it's too easy to be on the sidelines and to kind of comment on where they are versus not. It's much more fun being in the arena, kind of just like playing around with it and kind of taking a beginner's mind approach to it.
The thing that we find about it, of course, when you're, like, as you say, when you're in it, if you're designing the network yourself and what are the reward structures and things,
right?
It's a kind of, the word escapes me, parsimonious. Anyway,
sure.
One of those things where, you're using the minimum number of elements. So because of the limits of computation, you find it's telling you some truth about the physics, I think. You have a complicated experiment and you're able to shrink it down into a network, which is, I don't know, like 10 or 15 layers deep. That means your problem was not really that deep. It's just you were holding on to a lot of physics baggage in between. And you were asking not just that the inputs and outputs must be accurate, but that the thought process must be accurate. And I don't know about your school experience, but all through elementary school, I used to hate this thing where the teachers would come in and say, so you got the answer in this math problem faster than everybody else, but you didn't show your work in the right way. Like you have to put a box around the square root and do this other. I'd say, what a useless bunch of trash. Who cares?
I completely agree with this.
There's the input and the output. It's math. There's no cheating in math. If you get the right answer, you get the right answer.
It's funny you say this because I was a very good student, okay? But part of my hack for being a student was that it turns out that like if you follow any of these courses, whether it be International Baccalaureate or you follow the CBSC, ICSC in India, whatever be the case, they're all basically, it's kind of a standard. They're like, hey, a student must know these concepts when they kind of like matriculate, right? So I was like, I don't want to read the textbooks. I'll just read the standard. So like, this is what they expect me to know and learn. So I'll just learn that, right? And then I'll figure out some way of like how it all makes sense in my own head. And based on that, I did fabulously on my exams because I was like, I don't want to learn the intermediate steps. I just want to learn the outcome and I'll figure out like, as long as it makes sense in my head, I'm good. But that was very frustrating for my teachers because they all would accuse me of finding the shortcuts. And I'm just like, but it's not a shortcut. Like this is the shortest path, right? There is a difference between those two things.
Yeah. If they want us to learn something else, they should not test us on something else.
Correct.
We know that in training networks that
yes, exactly.
Like the network will just satisfy the reward function. So don't give it the wrong reward. Give it the right reward. And that's what then you get what you want.
I mean, put another way, I think that sometimes these networks, instead of us assigning humanity into it, sometimes these networks teach us something about humanity, Like maybe that shit isn't as complex as we made it out to be. There's actually a much simpler form of it.
There's a class here called Order of Magnitude Physics.
Okay.
I don't teach that class because I'm just not good enough yet. But I yearn when I grow up one day, I'll know enough physics to teach it. But it is that kind of hack where someone asks you, like things like how many bowling balls can fit inside the Empire State Building or something like that. And you have to use, it's like a street fighting physics or something. You don't have time to go through and say, well, let's see what Einstein had to say about that and read a book or something. But you just use the first cheat that you can find that will get you to a limit that's within the order of magnitude. And once you're there, job is done. And so the whole point of that class is how quickly can you be on your feet and get to that answer. And learning that skill, like the people who take that class and enjoy it and do well, it's a great predictor for their future career because it means they have the ability to kind of get to the essence of the problem as fast as you can. And then the rest, it's iteration, but then you can bring in a team and figure out how to do the fine tuning or something.
I think I kind of want to audit this class because I think if you can basically develop great intuition and, in some ways methodology to get to the right order of magnitude for most problems, you are going to be winning, right, at whatever you choose to do. That's very valuable. Anaji, tell me a little bit about the work that you have done with LIGO in India, because you've kind of gone from a mechanic to an experimental physicist to now you kind of are, it's not easy to get all of these different, academic organizations, governmental organizations across multiple continents, all trying to coordinate. So tell me a little bit about that. I would love to, what's the latest with that? What have you learned from that maybe is interesting?
Wow. It's just one of these things I would have never seen myself doing, because anyway, you know me, I'm not that kind of person. My happy place is to be in the lab where there's no people. It's just me and a bunch of machines. Yeah. And that's my jam. That's just me and the stuff. And they don't have any kind of emotions or feelings. The equipment, it's pure. It's pure in that sense. But when you want to do these large experiments, it's really a people problem. It's not a science problem. We know quantum mechanics, we know gravity. That's enough to get us to this point. But the truth of it is, like, if you really want to know what's happening in the universe, you have to find out what's happening with black holes. That kind of like the black hole is the place where, like, we can't bluff you anymore and try to convince you that we know what's going on. When you really look at a black hole, and if you started asking me questions about black holes, even if you didn't have a physics background, within 5 questions, you'd run into the limit of my knowledge. And that's embarrassing for me. I think I really want to find out what's happening there. That's just I can't let it go. Since I was a teenager, this thing has always bothered me. What's going on at the edge? What's going on inside? And for that, we really need another LIGO detector in India. And you can easily understand that from the fact that the Earth is round. We have 2 LIGOs over here in the United States. We have a few more in Europe, some in Japan, but there's nothing in the South. And it means basically, like, you can't triangulate. You can't figure out where the signals are coming from. But more importantly for gravity is, there's a thing about gravity where you think that the waves can only come in a certain flavor. Like, either they're stretching and compressing like this or a little bit clocked like this. But you can't have any strange other modes where the whole volume of the space is increasing, or there's some symmetries about general relativity which say this is all that you can have. And there are no other flavors. And with India, we'll finally be able to test, like, is that really true? Or is that just something that Einstein said? And it's like, it's in the textbooks, so we all believe it. And there's no real hard test about this. Does the polarization of waves get distorted as they travel through the universe? Is the number of dimensions in the universe, the number of spatial dimensions, is that always been 3 dimensions? Or was there a time in the universe where we were 4-dimensional or 2-dimensional? Why 3? Why not 3.5? Why not 17? These are all things that you can explore if you have essentially a baby picture of the universe, like a sonogram. Like, you get a sonogram when your children are pre-born, before they're born. You find out what's going on inside. We'd like to find that out about the universe. What was the shape and the flavor and the composition of the universe at the beginning, and then what is it now? And with gravity, we have that ability to look at it because we get signals from really early in the universe, when the universe was maybe 1/10 of its current size. And so we can find out everything by just looking back through cosmic time and finding out about how the number of dimensions have unfolded and turned into 3 or compactified, if that's the truth. And so we had some options. We could put a detector in Antarctica. That's tough.
Too hard.
Too hard. We could put it in Australia. That would be fine, I think. Australia, however, has a population which is much smaller than California.
20 million, I think, maybe 30 million, something like that. Yeah.
So it would be like the state of Florida making its own LIGO or something like that. It would be like punching really high, something like that. But India, man, like, India has loads of people who are great at mathematics and computer science. And it's an extremely academically oriented country. And the human resources we have there mean that, not only can we build a LIGO detector, but we can build something that's beyond what the US has done. We have that as a kind of jumping point. But if you think about the talent in India and physics and mathematics, we can leapfrog what's happening everywhere else in the world and make this one the best. But yeah, as you said, it's tough because it's not just writing some equations and saying, look, you can see on paper due to this plot, you should do it, and therefore you do it. People don't really work that way. And I look more Indian than I am. I was born in the U.S., so I have this accent that I do because I grew up in the South. So I'm American in Indian clothing in that sense. But in 2008, I was invited to a conference, so I went back to India, and I thought I would bring my parents with me because we haven't taken a family trip in a while to see. And so we've gone to see our relatives, and my grandmother there said, it's great that you're doing good in science, but why can't you come back home and do this stuff? Why do you have to be abroad in this other country and do it all here? And I gave her some kind of answer, like you give your grandmother, say, oh, I would love to do this, do that, but I blah, 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 something. But then, I'm taking the train later, and I thought, I don't really have a good answer for that. Why is India not doing this thing? And so I went to that conference and I made the appeal, like, come on, people, there's 1 billion people here. And you can't tell me you can't build this little L-shaped thing. Let's do it. And I think there was a lot of interest at the time, but it just didn't really hit the critical mass where there was enough people that wanted to do it. But now people have seen, look, it's a proven thing, at least at this level. It's been done in the US, it's been done in Italy, it's been done in Japan, Germany. For sure, India can do it. And the potential impact from the Indian detector would be profound. But to make it happen, you have to really fight against. There's a lot of cultural problems. There's a lot of problems with funding, land acquisition, government approvals. I can't go into the whole, behind the scenes sausage of that thing. But for me, not growing up in that environment, it's been a huge learning experience. The difference between how people see science in the two different countries, how funding is allocated, how big projects are approved and managed. It's an enormous difference. Just in the US, I would say there is this project management culture where there are Gantt charts and things like that. You have meetings and design reviews, and that I think it exists in India and other places, but not as much in academia. And that's a thing that's now coming in. But you can see big projects have happened, right? Nuclear power plants exist, airplanes, big roads. There's great works of construction that have happened, but nothing at this level of high precision, I think. And so this is a challenge in that sense, to bring in high precision, but then do things on budget and on schedule in a proper way.
It's interesting. I definitely think that sometimes when you go outside of your immediate environment, right, and you see interesting big things happen, whether it be China or India, you kind of realize there's a design space of getting hard things done that might not map exactly to the way you have done things. And it kind of looks like madness. You're like, why would anybody want to do it that way? But then you have to sometimes, especially being in India, we obviously have South Park Commons in Bangalore now. I have come to appreciate that there's more than one way of doing the same thing, right? And you have to approach it with curiosity before you approach it with judgment, I think is kind of the way I look at it. And it takes some patience, but ultimately I think you end up learning a lot also, even kind of transferring it back to your day-to-day. Ranaji, we have almost out of time, so I'm going to ask you a rapid-fire last question. What would you say is the biggest myth about black holes today?
The biggest myth is that when you cross the black hole horizon, that it's all over for you, or you've been destroyed, or something like that. But there's nothing like that. There's nothing magic that happens at the horizon. It's only if you're outside of the black hole that the horizon seems magical. But if me and you were taking a trip, there's a massive million solar mass black hole someplace, and we decide to investigate it as astronauts, nothing will happen to us. You and I are sitting in some lawn chairs and slowly falling into the black hole, and we continue to have our martinis, and there's no drama.
Oh, interesting. So there's no almost, I'm not torn apart and kind of wrenched apart. So what is my experience? Do we know, or is that something you need to figure out? Like, what is my lived experience of kind of going past the event horizon?
You wouldn't be able to tell the difference. You won't even know you've crossed.
But that is the myth. That the myth is that something wild and kind of like, I see. Interesting.
Now, is that true, what I'm saying? That's the thing. Like, how
That's
do
the
you know
question,
that
right?
you can talk to random scientists on YouTube and everyone will give you some sort of different answer. But I'm just trying to say, no matter what people think, the fact is there's no evidence that anything magical happens there. And I believe what Einstein says is pretty true. I mean, so far so good, but I think the real maybe there's another myth, which is if you go deep enough into the black hole, that there will be a true singularity, and that there will be a final point at which all laws of physics break down, or something like that, and some madness happens, and you enter another universe or other kind of sci-fi things. And I can tell you, I'm not going to crush any of your hopes here. What I can tell you factually is that we just don't know. There's no matter what you hear on YouTube, physicists do not know what happens at the center of black holes.
And that center could be very far away from the event horizon. Like, we don't know, right? Like, that center could actually, interesting.
I mean, it can really be like there's another universe there, but it's nothing like there's no space, there's no time. It's just a thing that's just like a psychedelic hallucination from our view. But it's a real thing where there's, entities living their real lives down in the center of the black hole.
I mean, I don't think I've had a stronger ending to a particular podcast than to kind of, talk about what happens at the actual center of a black hole. Ranaji, it's always a pleasure. Thank you for coming on board. I hope to do more of these. I think that part of the conversation with a dear friend and kind of a brilliant mind is that they leave you with more wonder and joy about the world. And in some ways, more humility, right? Like, man, like it's what a gift to live in this world where we have all of these questions that we can pull on these threads, and that you leave with more curiosity and joy, as opposed to kind of like, it's just like, the world is like infinitely like interesting and joyous,
There's so many threads to pull, and I can promise you, if you pull on those threads, what a joy. I mean, you can pull, you get answers. There's threads of all different kinds.
Right.
People should get out there and investigate more things. I'm only going to solve certain mysteries in my lifetime, but the mysteries abound, and the best I could do is give people more mysteries at the end of my life.
Amazing. Well, thank you, sir. I will have you on again. All right, that's a wrap. That was another episode of -1 from the team at South Park Commons. Make sure to subscribe to our show wherever you listen to podcasts, and find us on social at South Park Commons. And thanks to our friends at Atomic Growth for their support in bringing this episode to life.